Welcome to today's explainer. I am absolutely thrilled to have you here because we are breaking down the fascinating science of fire. But we aren't just looking at this in some controlled laboratory. We're exploring how merchant ships and their crews survive the ultimate high-stakes nightmare of fire at sea. Think about it. When you're out in the middle of the ocean, you can't exactly dial 911. You are the fire department. So let's get into the incredible science and strict protocols that keep these sailors alive.
Okay, let's dive right into this. Today we're going to cover deconstructing the fire tetrahedron, the 6 classes of fire, the fire extinguisher arsenal, SOLAS regulations at sea, critical inspection and maintenance, and finally, advanced shipboard safety gear.
Section 1. Deconstructing the fire tetrahedron. To defeat our enemy, we really have to understand how it lives and breathes. For a long time, people talked about the fire triangle, but science actually updated this to the fire tetrahedron, or fire trident. A fire is a chemical reaction that absolutely requires 4 distinct elements to survive. You need fuel to burn, heat to bring that fuel up to its ignition point, oxygen to sustain the combustion, and finally, an uninhibited chain reaction connecting all of it together. It's like a giant puzzle. If you have fuel in one corner of a room and oxygen in another, you don't have a fire. They have to combine. And the golden rule here, if we remove even one of these 4 elements, the fire dies. That brings us to our methods of extinguishment. We call this the rule of exclusion. Killing a fire is entirely about depriving it of what it needs to survive. If we use water, we're using the cooling method to remove the heat. If we shut off a valve supplying oil, we're using starvation to literally cut off the fuel, blasting the area with carbon dioxide while we are smothering the fire by pushing the oxygen out of the way. And if we use special chemicals, we can actually pull off chain breaking, chemically interrupting the reaction itself. It is pure tactical science. Moving on to Section 2, the 6 classes of fire. Not all fires are created equal, and this is where things get tricky. The fuel source completely dictates the classification, which in turn dictates our choice of weapon. Fighting a fire with a wrong weapon can literally make it explode. So, Class A and B cover your common solids and liquids, think wood or diesel. Class C is gases like methane, while Class D involves combustible metals burning at just extreme heat. Class E is a supercritical one, energized electrical fires, like if a generator short circuits. And finally, Class F, sometimes called Class K, is specifically for cooking oils and fats in the ship's galley. Memorizing these is step 1 for any sailor. Section 3, the fire extinguisher arsenal. We know the classes, now let's look at the specific weapons we use to kill them. Here is your shipboard arsenal. There are 5 main types of portable extinguishers. When alarms are blaring, you don't have time to read the fine print, right? That's exactly why they're color-coded. Water extinguishers have a bright red label. Great for Class A paper fires, but incredibly deadly if you spray it on an electrical fire. Foam has a cream label, perfect for smothering liquid fires. Dry chemical powder, or DCP, features a blue label. That's your versatile workhorse for Classes A, B, and C. The CO2 extinguisher has a black label and is your absolute go-to for electrical fires. And finally, wet chemical with a yellow label is specially designed for those tricky Class F cooking oil fires. Let's see how this plays out in the real world, inside a ship's engine control room. You'll typically find both a 5-kilogram CO2 extinguisher and a 6-kilogram dry powder extinguisher sitting right side by side. Why? Because each serves a highly specific tactical purpose. If the main electrical switchboard catches fire, you use the CO2. It's non-conductive, leaves 0 residue, and saves millions of dollars of sensitive equipment. But what if a pile of logbooks catches fire? You grab the dry powder. It handles the solid fire perfectly, whereas the CO2 might just blow all those burning papers around the room. It's all about having the exact right tool for the job. Section 4. SOLAS regulations at sea. You can't just throw a random extinguisher on a ship and call it a day. You are bound by international laws. 23 kilograms. That's about 50 pounds. Under SOLAS regulations, that's the safety of life at sea, that is the absolute total maximum allowable weight for a portable fire extinguisher. That includes the body, the media, all the attachments. Why?
Because in a total panic, any crew member, regardless of their size or strength, needs to be able to lift, carry, and fire that thing immediately. On the flip side, we have 5 kilograms. Solace dictates that if you're relying on a dry chemical powder or CO2 extinguisher in certain critical spots, it has to contain a minimum of 5 kilograms of the actual extinguishing media inside. This just ensures that the weapon in your hand actually has enough fighting power to put down a significant fire before it spreads. No wimpy extinguishers allowed. 100%. Isolation in the middle of the ocean demands absolute readiness. SOLAS mandates that ships must carry 100% spare charges for their first 10 extinguishers and 50% for the rest. Think about it. If you use your equipment fighting a fire on Tuesday, you have to be able to completely recharge and reset your entire arsenal for Wednesday. Now, location is another crucial factor. CO2 extinguishers are amazing for electrical fires, but they are strictly prohibited in accommodation spaces. The places where the crew actually sleeps and lives. The reasoning is chillingly simple. CO2 kills a fire by completely displacing the oxygen in the room. If a crew member sets off a CO2 extinguisher in a tight, closed sleeping quarter, they run a massive risk of suffocating themselves and their crewmates. Let's jump to Section 5. Critical inspection and maintenance. Because out on the ocean, the elements are constantly trying to destroy your gear. A weapon is only as good as its upkeep, right? Merchant crews execute this incredibly precise, step-by-step annual procedure to keep their dry chemical powder extinguishers ready. First, they visually inspect the body and hose for any dents or corrosion. Second, they literally unscrew the top and weigh the small CO2 propellant cartridge inside. If it's lost more than 10% of its weight, it gets tossed and replaced immediately. Third, they check the actual powder. If it absorbs moisture, it turns into a hard rock and won't spray. So if it's caked, they dump it, refill it with fresh, free-flowing powder, and tag it with the exact inspection date. It is meticulous. And the testing goes even deeper. Surveyors require that at least 10% of the ship's extinguishers are literally test-fired in action every single year. The metal bodies might even undergo UV testing to detect microscopic cracks that the human eye just can't see. Every pin and latch is checked. Plus, because ships deal with massive storms and crazy engine vibrations, the storage brackets aren't just screwed in, they are often welded directly to the steel bulkheads so they don't become deadly flying projectiles in bad weather. Finally, Section 6. Advanced Shipboard Safety Gear. What happens when the smoke gets too thick and the fire is just too big for a portable extinguisher? There is a life or death difference between these two pieces of equipment. On board, you have the SCBA, the self-contained breathing apparatus. This is the heavy-duty gear that provides clean air, allowing a trained firefighter to actually run into a smoke-filled room to fight the battle. But on the other hand, you have the EEBD, the Emergency Escape Breathing Device. It's just a small hood that gives you a very short supply of air. It is strictly designed for one purpose: running away. You put it on to evacuate. You never, ever fight a fire wearing an EEBD. Before a crew member even steps foot into an enclosed space where a fire might start, they rely on their invisible shield: portable gas detectors. Oxygen detectors ensure there's actually air to breathe. Flammable gas detectors warn of explosive buildups. Toxic gas detectors sense deadly, invisible poisons like carbon monoxide. Most of the time, crews just use a multi-gas detector that checks all of these at once. And on chemical tankers, they use VOC detectors for long-term harmful vapors. Basically, these devices sense the deadly threats before a human lung ever takes a breath. Which brings us to the end of our explainer. The science of fire is structured, it's logical, and it's actually completely predictable if you understand its anatomy. So look around the room you are sitting in right now. If a fire broke out right this second, do you know exactly what class of fire it is? And more importantly, do you know which color-coded weapon you need to reach for to kill it? Thank you so much for exploring this with us today, and keep learning.